Let's solve problem 2.6 for Microelectronic Circuits 8th edition by Sedra and Smith. Two amplifier inputs are expressed in each row of the table below, either in terms of their node voltages with respect to ground, V1 and V2, or in terms of their differential and common mode voltages, VD and VCM. We just want to fill in these missing values. Let's start by just briefly reviewing all of the different inputs and outputs of a voltage in the op amp. So we call the output voltage VO usually. We usually call the voltage at the positive rail V2 and the voltage at the negative rail V1. VD is just the difference between V2 minus V1. In VCM, the common mode voltage, I usually think of just combining V1 and V2 in the one wire, just driving into the middle of the op amp, because it's simply the average of the two. And if we know VD and VCM, we can actually find V1 and V2. V1 is equal to VCM plus, or excuse me, minus VD divided by 2. Whereas V2 is VCM plus VD divided by 2. So with this information, we should be able to start working through row A. We have V1 and V2. So you can find VD pretty easily. It's just V2, which is 0.9, minus V1, which is 0.9, which is 0. And VCM is going to be V1, 0.9, plus V2, 0.9, divided by 2, which is equal to 0.9. Okay, let's start solving for row B. So we have VD and VCM this time. So you can solve for V1 and V2 directly. So V1 is equal to VCM 1 minus VD divided by 2. 0.5 divided by 2. That's just 0.25, right? It's going to be 0.75. And then V2 is just 1 plus 0.5 divided by 2. So we're just adding 0.25 to make it 1.25. All right, let me erase this and we'll continue solving. Okay, let's solve for row C. Here we have V1 and VCM. I have this equation here for VCM equals V1 plus V2 over 2. So I can just do some algebra to isolate V2. So if I multiply both sides by 2, we get 2 VCM equals V1 plus V2. Then I just need to subtract V1 to the other side of the equation. So you get V2 equals 2 VCM minus V1. Therefore, V2 is equal to 2 times my VCM is negative 1.1 minus V1, which is negative 1.2. And so I get V2 is equal to negative 1. And then we can solve for VD, right? VD is just equal to V2, negative 1 minus V1, negative 1.2. And that is going to be equal to 0.2. Okay, let's solve for row 4. Call this D. This one's just like row A. We can solve for VD directly. It's V2, 0.05, minus V1, negative 0.15. That's equal to 0.2. And then VCM is equal to V1, negative 0.15, plus V2, 0.05, divided by 2. So that would be negative 0.05. All right, let me erase this and we'll solve for row E. Okay, let's wrap this problem up with row E. We can solve for V1 directly. It's equal to VCM, 0, minus VD, negative 0.2 divided by 2, that is equal to 0.1. V2 is equal to 0 plus my VD divided by 2, that is equal to negative 0.1. And that completes the problem.